Okay, so we're just working on this daily math review right now. Keep in mind that tomorrow we will do a quiz on this daily math review. It'll be really similar to similar setup to what we did last time. So today, kind of your last chance to ask questions. If any of this stuff is giving you any kind of a challenge, struggles, certainly willing to help you through those. So let's take a few minutes here and work through numbers 1 through 4. So let's go over some answers to this and see how it all went for you. So number 1, what do we got? Negative 11. Okay. Number 2, negative 20 plus 9. Whoa, negative 11?
Yeah.
Interesting. Didn't intend that, but whatever. Is number 3 also negative 11?
No.
All right. Well, let's look at the steps here. Numbers 1 and 2 are basically all addition or subtraction. It's basically one level of order of operations. Number 3 is multiple levels of order of operations. I can say this again. Some of you are probably like, really? Are you saying it again? Isn't it tempting to read from left to right? Yeah. Isn't it tempting to be like, oh, look, negative 3 plus 2, that's negative 1, parentheses, blah, blah, blah. That's wrong, though, right? You're reading in the wrong order. So instead of reading from left to right, we want to read according to order of operations. So that means we got to do all the work in the parentheses first. So inside the parentheses, I see 4 squared, which is 16. And then over here, the absolute values are also sort of a grouping symbol. A minus 11 is negative 3. Continue to work the parentheses here, the work inside the parentheses. Negative 3 plus 2, parentheses. 16 minus 13 is 3. And inside the absolute values, the absolute value of negative 3 is 3. So it's just minus 3. So we've covered all the parentheses. We did the one exponent that was inside the parentheses. We're down to multiplication or division. Do you guys see any multiplication or division? 2 times 3. Yeah, you're right. So we'll do that next. Negative 3 plus 6 minus 3. Oh, this ends up being 0, doesn't it? Yep. Cool. Okay, so your final value there would be a 0. And then the last one, at what age is the value of the machinery $10,000? So we're using the same graph that we did before, but we're asking sort of a different question. It's a little bit better there. So this time we're going to go on the y-axis first, right? We need to find $10,000 on the y-axis, and that would be there. There's your $10,000. So I'm going to try to draw straight across, like so. So I'm thinking about 40 years. Does that sound about right? So I just say 40 years to match up with that $10,000. So before we've been looking at all the inputs and trying to figure out what the output was. This time we looked at an output, try to figure out where that input would be, so 40 years. Okay, so you've had a chance to look at all 4 of those, the answers there. Do you guys have any follow-up questions? I was asking the table in the back there, is this structure making sense? Is this working for you?
Yeah.
The idea is that maybe on Monday some of these questions are like maybe sort of difficult, or maybe they're difficult or whatever, but the idea is through the week it should get easier, right? Uh-huh. By today you should be like, okay, I think I might be able to do this pretty well. And then tomorrow is the quiz, and so does that make sense?
Yeah. Mm-hmm.
Hope it's all working for you. If you have any concerns, and you want to talk in private or whatever, send me an email, send me a note or something. I'd be happy to discuss with you. Last chance for questions on that. Love to help if needed. Okay, so today. Today is, as you saw up here, all about fractions. So does that scare anybody? You have a song for fractions? Ooh, I love it. I have not heard a flip and multiply song or poem or whatever that was. That was pretty good. I like it. Dividing. Well, you know what? Oh, there's a fraction, a division of fractions there. So there's a lot of places we can go with this. The assumption is that in your middle school you at least saw this. Maybe you have it mastered, maybe you don't. But we're going to go through this here together. We're going to do kind of all the different operations. We're going to add or subtract. We're going to multiply. We're going to divide. We're hopefully going to make sure we get to a place where we're all pretty good with these. We can draw little pie diagrams. We can do all kinds of stuff to kind of help with this. But bottom line is we need to be good with this, for sure. So kind of like we normally do, I'm going to do a couple of examples here with you. I'll give you guys a couple of opportunities afterwards to work on these on your own. We'll kind of see where we're at. We'll see what we do from there. I'm not sure exactly how much time this will take. So take a look at number one. Number one is very clear in the instructions. It says add. So I want to kind of quiz you guys. I want you to think about this. When you are adding fractions, there is one condition that must be true in order for us to add the fractions. What is that condition? Well,
Common denominator.
Common denominator. Now, that's only true of addition and subtraction. You don't have to have a common denominator for the other operations. But for addition or subtraction, you do. So this is where, I don't know how this is going to go. We'll just kind of see here. You can see that the two denominators are definitely not the same. They need to be the same in order to add these fractions, and they are not. And so we need to make them, and we can. So here's what we need to think about. We need to think about the least common multiple, or also known as the lowest common denominator, of 9 and 7. So we need to multiply those up to a point where they're equal to each other. So does anybody know what that least common multiple would be for 9 and 7? What do you think there, Ben?
63.
It is 63. So one kind of foolproof way to do this is if you can't think of what the least common multiple is, you could just multiply the two together. And that will at least be a common multiple. You might have to do some pretty serious reducing afterwards, but at the very least, that'll get you somewhere good. So here's what we're going to do. I want my denominators to be 63, and right now they are definitely not 63. So here's what I'm going to do. I'm going to ask myself, how do I get them to 63? So for instance, the one that's a 9, what do I need to multiply the 9 by to get to 63?
7.
So what I'm going to do is just go times 7. But you guys, I'm sure, are aware, you can't just multiply, bless you, the denominator of a fraction by something unless you also do the exact same multiplication to the numerator, right? So if I multiply the denominator by 7, which I have to balance that out, I have to multiply the top by 7 as well, the numerator. I don't know if you guys, you probably already know this, but if I multiply the top by 7 and the bottom by 7, what am I really multiplying by overall?
7.
No, not 7. What's 7 over 7?
1.
This is actually a really smart 1. 7, I'm really just multiplying by 1. So I haven't changed the value, I'm just going to change the form. Okay, so I multiply the first question, or the first fraction by 7, top and bottom. Let's focus on the other fraction here real quick. For that one, the denominator right now is a 7. What do I have to multiply that by to get to my 63? 9. So I'm going to multiply by 9 on the denominator and 9 on the numerator. And of course, that is also just a really smart version of 1. I multiplied by 9 over 9, essentially. Let's go ahead and do those multiplications and see where this goes. So 7 times 4 is 28. 7 times 9 is that 63 that we were looking for. And then over there, 3 times 9 is 27. And once again, 7 times 9 is 63. So now I've transformed these fractions from not having common denominators to having that common denominator. The final task is, how do I actually add these? Now that I do have a common denominator, how does this work mechanically? Do you remember? What happens with the denominators?
It doesn't change.
Stays the same. That's right. So the denominator is going to remain 63. What do we do with the numerators? We actually add them up. Yep. So 28 plus 27, 55. And I don't think that reduces, so we just leave it as 55/63. So this is all something you've probably seen. I don't know if it's all something that you have like really mastered or grasped. Maybe it is. If so, that's great. Any questions? Josh?
Is this anyone's water? Because it was
It's
just
been sitting here since first period. I have
Really?
no idea.
Can I
Is it-
just take it? I'm kind of thirsty.
Let's, if you're thirsty, go get a drink. If you want, somebody could come back for it today. You never know. It could be their water for this
But
afternoon.
it's not open.
Well, that's what I'm saying. Like,
Oh.
yeah, they might have accidentally left it here. Okay, so again, I want to give you time and space. Do you have any questions? All right, well then let's take a look at number 2. Believe it or not, sometimes people will get mixed up on this. Sometimes they'll do this when they're supposed to do that. Why do you think that is? Why do people like multiply when they should add or add when they should multiply?
Because they're not paying attention.
They're not paying attention to symbols. Yes. You really just want to be really careful here and make sure it's clear. I'll try to give you clear instructions where possible, things like multiply or add or whatever, but this is a multiplication. So with adding and subtracting, you have to have a common denominator. With multiplication, you don't. There's a number of things you could do with this. If you wanted to, you could just start off by doing this. I'll show you a couple of options. If you wanted to, you could just multiply. The way you multiply fractions is you multiply the numerators together, and 4 times 3 is 12. And then you multiply the denominators together. 9 times 7 is?
63.
We figured that out already, 63. Now this fraction actually can be reduced, can it?
Yeah.
What goes into both 12 and 63?
3.
3 does, yep. So that would be 4 21sts. 4 21sts. Was anybody thinking, like when I was doing that, that there might be a different way? What do you think, Joe?
Cross multiplying.
Not cross multiplying.
Cancel.
Let's take the hybrid of what you guys just said. How about cross cancel? Cross multiplying would actually be bad news. That would get you in a bad spot. But cross canceling would work really, really well. So here's what you could notice. You could notice that this 3 and this 9 already have a common factor. Like you could reduce it ahead of time. So what you could do, and this would be the notation a lot of folks use, is they will say this 3 and this 9 cancel out. They cross cancel to be a 1 and a 3 because 3 goes into both. And once you've done that, you would just proceed like we did before with the multiplying straight across. 4 times 1 is 4. 3 times 7 is 21. So cross multiplication is something else entirely. That's when you have a ratio equal to each other, and you cross multiply across an equal sign. We
That's-
don't do that with times.
That's what I meant.
Yeah, cross cancel. I figured you knew what you meant, but yeah, cross cancel is what you'd call that. Okay, so multiply right there. Questions? Okay, fantastic. So then I've got a third one here, and this one has a little bit more going on. This one says simplify, and did you notice there's addition and subtraction, and there's 3 fractions instead of 2? So let's check this one out. The rule is, of course, for addition and subtraction, you have to have a common denominator. But instead of just having 2 denominators, this time we have 3. So 3 denominators are 7, 5, and 35. So what we want to think about here is what is the smallest number that those go into. What's the least common multiple? What do you think?
35.
It's 35. Yeah, 35 is it. So what I'm going to do is just rewrite this real quick. It's going to be 3/7 minus 2/5 plus 2/35. And as Colton pointed out, the least common denominator, lowest common denominator is 35. So let's go ahead, like we did on number 1, let's go ahead and get those denominators where we want them to go. Okay, so Callie, on the first fraction, what do I have to multiply the denominator by to get to that 35 denominator?
On the first fraction. Sorry, I'm confused by the question.
So I want to get my denominators to all be 35s.
Yeah.
So I need to multiply this 7 by something, by 5, yep. And as I said before, you can't just multiply the denominator by 5 if you don't do the exact same multiplication to the numerator. So I'm going to multiply that by 5 also. And then the other one, Aiden, what do you think here? 2/5, we need to get that to be 35ths. So what do I need to multiply that denominator by?
You multiply by 7.
That's right. And then we do the same thing to the numerator. Exactly right. So at this point, I'm set up to have common denominators. And of course, the last denominator is already my common denominator. I don't have to do anything to that. Okay, so as I multiply here, I'm going to get 15 35ths minus 14 35ths plus 2 35ths. So let's just review this. When you are adding and subtracting fractions to get to the final result, how do you change the denominators to get to that final result?
Multiply. Oh, to the least common.
Okay, yeah, but once you get the least common denominator, to get to your final result, what do you do to your denominators? Nothing, right? You leave them the same, right? They're 35s. They're just going to be a 35 denominator. So this will be something over 35. Then what do you do with your numerators? You just add them up, subtract as needed. Yep. So 15 minus 14 plus 2. What is 15 minus 14?
1.
Plus 2, 3 35ths. Hanging in there still? Okay. Okay. And then I would like to hear the song.
Dividing fractions, dividing fraction. You copy, not flip, and multiply.
There was like a clapping to it too.
It's like a whole routine. I like
Yeah,
it.
was.
I like it. So this is our final one and final example here. And if we need to sing the song again, maybe I can sing with you or something. You can teach me the clapping and the hand motion.
Yeah.
Sing with us this time.
Some of you,
Hallie, please don't.
she's trying to get you guys to be creative. Nothing wrong with that. All right, well let's try this, and if you can get through this without a song or a poem or whatever, then we're good. So if you do have fractions, if you are dividing fractions, really? Really? Oh Lord. Don't make me go there. Are you guys going to be okay with the whole banging of chairs against each other?
We'll be A-okay.
It better happen, or you'll have a problem. I don't know what just happened there, but not cool. Anyways, Joe, you were about to say?
So you copy the first fraction,
Yep. Copy it.
and then you put a multiplication symbol in the middle,
Yep.
and then you flip the numerator and denominator on the last fraction.
So this is that copy dot flip. Yeah, copy dot flip, copy dot flop, sometimes people will say. So yeah, so you copy the first one, you leave it as is, you turn to division and multiplication, and then you do flip the second fraction. You're right. So then here you could do a number of things. I'm going to do the fast way this time. The way I do the cross canceling. Did you guys notice that 5 and 25 have a common factor?
And so do 23
And so do the, yep, you're exactly right. So this is 1, this is 5 because 5 goes into both. And then 23 goes into 46 how many times? Twice. So this reduces down to be a 1, this reduces down to be a 2. And then remember that when you multiply fractions, you multiply the numerators together. 1 times 1 is just 1. And then you multiply the denominators together. 5 times 2 is 10. So I'd come up with 1/10. So if you're dividing fractions, clap. If you're dividing fractions, you copy dot flip, right? Yay. Okay. So you guys have a chance to practice this now. So if you guys would flip over to the next page, you will see some of these. Instead of going to the board today, I want you guys to work in... Oh, shoot, we have an application. I forgot about this.
Oh, yeah.
Let's do this first. And then we'll do our practice ones. Okay, so application. Sorry, I forgot about this one.
Yeah.
A recipe calls for 3/4 cup of sugar, but you're running low. You find out you only have 1/3 of a cup, and you're going to go borrow some from a neighbor. How much do you need to borrow, right? So let's think about what you'd need to do here. What do you think, Ava?
Oh, I already got the answer.
I don't know what the answer yet. I want to know what you'd do.
I subtracted 3/4 from 1/3. No, sorry, 1/3 from 3/4.
Okay. So 3/4 minus 1/3. Let's stop and think about that. Does that make sense? We need 3/4. All we have is 1/3. We need to know how much we need to get to make that difference up. And so, yeah, 3/4 minus 1/3, I think that makes a lot of sense. Okay, so again, sort of practical, right? What would you do next if we're trying to actually figure out kind of a final solution to this? What do you think, Whit?
Figure out the common denominator.
Because we're subtracting, right? Yeah, if it was multiplication, we don't need to do that, but we do. Anybody have a suggestion on what that common denominator would be? 12, yep. So for the first fraction, the denominator right now is 4. So what do I need to multiply that 4 by to get to 12? 3. So I'm going to multiply the denominator by 3. And if I do that, I got to multiply the numerator by 3. What about the other one? The current denominator is 3, but I want it to be a 12. So I need to multiply by 4. And the denominator and times 4 in the numerator. I can go ahead and simplify these. 9/12 minus 4/12. One last chance to do this. Victoria, when I'm subtracting fractions, what do I do with my denominators to get to that final answer? Keep it the same. And what do I do, Victoria, with my numerators? Yep, so 9 minus 4 is 5. We need 5/12 of a cup. I don't know where you're going to find that, but that's what you need. Okay. Any questions? Now let's practice. So flip over, and let's do some practicing here. 1, 2, 3, 4, 5. Hi, Mariah. What's up? Your question? Give me 1 second. I'll at least get those there. Okay. You guys are doing okay. I think this is an encouraging work here with these fractions for sure. Okay, so number 1, the 5 really does have a denominator, even though it's not there. What is it really? It's really a 1. So I'm just going to write that in as 5 over 1. So when you're going to try to add or subtract subtract in this case, you have to have that common denominator. Chase, what should that common denominator be for number 1?
3.
3, yep. So obviously the 8/3 already has that. So what do I have to multiply the first denominator by to get that?
3.
3, yeah. So I'm going to go times 3, and I've got to do the same thing to the top. So it ends up being 15/3 minus 8/3. So once I get to this place, Faith, 15/3 minus 8/3, I want to get my final answer. What do I do with my denominators?
You keep them the same.
That's right. And then what do I do with my numerators?
You subtract them.
And 15 minus 8, we get 7/3. Okay, so take a look at what you have. Take a look at what I have. Does it all make sense? Any questions? Do you think it was something different? We're good? Okay. So number 2, division. 1/2 divided by 7/8. Mariah?
I turned 3 over 7 into 2.
Sorry, I'm having a hard time hearing you. Say that again.
I turned 7 over 3 into this. That makes sense.
Oh, you were going back to number 1. I'm so sorry. I thought you were talking about number 2. Oh, okay, gotcha. So what Mariah is saying is she wrote this as 2 1/3. What do you guys think about that?
Yeah, it's just an extra step.
100% correct. It is an extra step. In my opinion, I like this a little bit better simply because it's easier for you. The extra step thing. So Mariah, if you're okay with leaving it as 7/3, I would like for you to do that just so it's easier for you. I totally get what 7/3 means. I'm okay with it. But if you do go to 2 1/3, I would never mark that wrong. It's obviously okay. Make sense, Mariah? Okay, cool. Okay, so number 2, 1/2 divided by 7/8. What is that saying when you have a fraction or something divided by a fraction?
You flip the 7/8.
Well, the whole saying is copy dot flop or copy dot flip, right? So copy dot flip, copy dot flop. So what I'm going to do here is I'm going to write copy. Dot means multiplication. Flop or flip means do the reciprocal of that second fraction. Okay, does anybody see that little cross-canceling trick here?
Yeah.
What cancels with what, Kyrie?
2 cancels with 8.
Yeah, so the 2 would become
1.
8.
And 8 becomes 1.
Perfect. When you are multiplying fractions, you multiply the numerators times each other. So in this case, we'd get 4. And you multiply the denominators together. So 1 times 7, I got 4/7. Doing okay? Okay. And then number 3, 3 plus 5/7 minus 2/3. So kind of like number 1, that 3 does not seem to have a denominator, but it really does. What is that denominator? It's a 1. That's right. So now we got to figure out, we're adding and subtracting. We got to figure out, do we have a common denominator? Because we have to have that in order to actually add and subtract these fractions. I've got a 1, 7, and 3. That's not going to work. What is that least common multiple of all those denominators? 21. Okay. So if my common denominator needs to be 21, what do I have to multiply the first fraction by? Or the denominator by? 21, right? Because right now it's a 1. So it's going to be times 21 times 21. It's going to be a pretty big number. How about the 5/7? I need to multiply top and bottom by what? 3. So I'll just kind of squeeze this in here. Times 3 times 3. And then the last one I have to multiply top and bottom by? 7. That's right. We understood. It was like a yawning 7, right?
Sounded like Sherman.
So any questions on that? Like, why did I multiply by the 21s, the 3s, the 7s? Any questions? All right. So 21 times 3 is 63. So you get 63 21sts plus 15 21sts minus 14 21sts. Still hanging in? All right. So then this will be one more chance to think about this. Whenever you're adding and subtracting fractions, to get to that final value, what do you do with your denominators?
Keep them the same.
Keep them the same. Thank you, Ben. Thanks for speaking up. 21. And Now let's add these numbers up. 63 plus 15 is?
78.
78 minus 14.
Oh, I was about to say.
I got 64 21st.
Oh, I got 63, didn't you?
So Ava and I were talking about reducing. She was kind of like, well, like what's the process on figuring out if you can or can't reduce, right?
Yeah.
So 64 21sts. I don't know what you guys learn in middle school, but here's maybe a few hints. 64 and 21, they only the 64 is even, but the 21 is not. So 2 does not go into 21, right? Do you guys know the divisibility test for 3?
You have to add the numbers together, and then if it equals 6, 9, or
Something that's divisible by 3, yep. So 21 is divisible by 3 because 2 plus 1 is 3. But 6 plus 4 is 10. That's not divisible by 3. So that doesn't work. You could try a 4, but 4 doesn't go into 21. In fact, what are the only two numbers that go into 21?
3 and 7.
3 and 7 and 21 technically, but 3 and 7 and 1. Yep, that's not going to reduce anything. So really the only other question is, does 7 go into 64 evenly?
No.
Nope. So this is it. That's your final value. Okay. All right. Number 4 is a nice order of operations. You've got 4 times 6/5 plus 2/3. According to order of operations, what do we have to do first? That's right. So maybe what we do is, for the third time, look at the 4 and realize it's really 4 over 1. And I'm going to go ahead and do that multiplication first according to order of operations. When you are multiplying two fractions together, Irene, what do?
you just multiply the numerator and denominator.
So I multiply a numerator times a denominator?
No, you multiply a numerator times a numerator and denominator times the denominator.
There you go. That's exactly right. I knew you were saying, but it just came out wrong. That was well said. So 4 times 6 is 24. 1 times 5 is 5. We still have that plus 2/3 hanging out there. That make sense? Okay. So we obviously are going to be adding here. Chase, we need a common denominator. What is it? For number 4.
For number 4, 15.
15 is right for that common denominator. So for the first fraction, Chase, multiply top and bottom by what?
3 and 5.
So 3 for the first one, 5 for the second one. Is it making sense to you guys? Okay. So then 3 times 24, sort of a bigger number. What's that equal to? 72. Yep. So 72 fifteenths plus 10 fifteenths. 82 fifteenths as we leave the denominator alone and add the numerators. So does 82 fifteenths reduce?
No.
You add.
So only 3 and 5 go into 15. 3 does not go into 82. 5 does not go into 82. So I think it's good. So Mariah, this would be a really excellent example of leaving it as 82 fifteenths is significantly easier, right, than going to that mixed number. So I'd encourage you to do that. Final one, the challenge question, which is larger, 11 twelfths or 8 ninths? What'd you do? Common denominator? Coy, what'd you get for a common denominator? 108, agreed. So I've got 11 twelfths and I've got 8 ninths. Coy, what did you multiply by to get to that 108 for either fraction? Okay, so times 9 over here, and on the other one times 12. Yep. So when you do that, you end up with 99 108ths, 108ths, and 8 times 12 is?
96.
So once you get it to be a common denominator, it actually becomes pretty clear which number is bigger. 99 108ths is bigger. That means 11 twelfths is bigger. That make sense? Question, Ava.
We have to show our work on those, or if we just look at it like it's it's bigger and then just say that.
I don't know what work you'd show other than if you just scaled them up like that. I don't know.
Different problems are different, but I mean,
Yeah.
if it's like 3/4 and 1/3, can we just say 3/4 is bigger? 'Cause
Well, to me, that's pretty obvious. So yeah. But this is a little less obvious, right? Because they're so close. I mean, they're only 308ths apart. Pretty close. So I don't know that this one is as obvious as the one you mentioned, because I agree that that one is pretty obvious. Sorry? Why are you guys packing up? What's up, Mariah? What time is it? 12:33.
Okay.